All right, so this video is going to be short by AG1H standards because I am only going to do the first page. The second page is sort of bonus extra extension. And seeing as how we're trying to combine 231 and 232, I'm going to try to make this brief. In past lessons, you learned facts about M and B by graphing lines from equations, and today you will reverse the process. So what we're going to do is look at a table that has a series of points. So for example, this 2997, this is a coordinate. It's an XY coordinate. The one next to it, 1864, that's another coordinate. And what we're doing is we're going to try to find what is the equation that goes with that table. And we're going to do it all algebraically, no graph. So first, we're going to identify that we've got a point 2997, and we've also got a point 1864. And that's what we're using to find the slope of the line using the formula. So we're going to do y2 minus y1 over x2 minus x1. We've got our y2 97 minus our y1 64. And then we've got our x2 29, take away our x. Oh, let me see. Yeah, 97 take away 64, 29 take away 18. I actually ended up using this as 0.2 and this is 0.1 when I just did that. It doesn't actually matter what order because you're still going to get the same outcome. I got 33 over 11 by putting the larger numbers first and the smaller numbers second, which is a slope of 3. If you had reversed them, you would have gotten negative 33 over negative 11 and still come out with a positive 3 slope. So does it matter what order? We would say no. So if I chose a different 2 points, so let's say I chose 1452, and let's say that I chose the negative 27, negative 71, I can do the problem again and again, I'm going to do large number, take away the smaller number, positive number, take away the negative number, 52, take away negative 71, over 14, take away negative 27. So that actually changes to addition. And by setting them up in that order, I made my life a little easier. And I get 123 over 41, which is still a slope of 3. Now, how can you use a point to finish the equation? So at this point, we know that m equals 3, but we don't know the intercept. We are going to plug in or substitute 1 point for x and y, because each one of those points, each one of those coordinates has an x and a y value in it. So we know that the slope is 3, so we know that it's y equals 3x plus b. I'm going to choose a coordinate where everything is positive. I'll just choose the first one, 2997. So 97 is the x coordinate, 3 times 29, which is the x. Sorry, 97 is the y coordinate, 29 is the x coordinate. The point was 2997, so that's my x and my y, and plus b, which I don't know. And so it's 97 equals 87 plus b. And I take away 87 from both sides, and I get 10 equals b. That's it, guys. All we added was the extra step up here of 2 points. You have to find the slope instead of being given the slope. And then you use the slope and one of the coordinates to find the b value. So we have y equals 3x plus 10. Once you have the slope, does it matter which point you use? Well, all of the points came off of the same line, and lines are linear. It's a straight line. So anywhere along that line should give you the same intercept because they're on the same line. So we would say, does it matter? No. All points are on the same line, so they will all be solutions to the equation. All right, how can you verify that your equation is correct? We can substitute any other point that's in that table or on that line. If we substitute any other point on that equation, on that line, we can prove whether or not it works. So let's say, for example, we want to use y equals 3x plus 10, which is our equation. And we want to use that with the coordinate negative 8, negative 14. And I just took that one off the table since we hadn't used it yet. I figured this was as good a time as any. And I am going to plug in negative 8 for x and negative 14 for y. And say, does negative 14 equal 3 times negative 8 plus 10. Does negative 14 equal negative 24 plus 10? And if I add negative 24 plus 10, I get negative 14, and we would say, yes, this coordinate was a solution to this equation. So substitute any point you have not already used into the equation to verify. Now, another option here, if this one isn't your cup of tea, because some kids don't like this one, having like the left side equal the right side, they feel like they should be getting an answer. You also could have used, let's say, 1864, and you could say y equals 3x plus 10, and just plug in one of the two. So just plug in the x coordinate and say, all right, if I plug in 18 for x, I should get out 64 for y. And I would do 18 times 3, which is 8 times 3 is 24, 3, 4, 5. So it's 54 plus 10. Y comes out to be 64, which works out because we knew it should be 64. So 2 different options for verifying that your equation is correct. You can either substitute in the whole coordinate, see if the left side equals the right side, or you can substitute in just the x value and see if you get the correct y value as your outcome. So again, the second page of the notes are all filled out for you, but I'm not going to go through all of them in the interest of time. And if you do have any questions, feel free to ask in class. Happy to go over them then. Bye.